Good morning. Good morning. Still, students have to come. Okay. Okay. So good morning to everyone. So what I will do is I will brief whatever we have discussed in the last class. Fine. So we have started with anyone? Any one of you can tell me? We have started with So we have started with KMnO4. So what do you mean by KMnO4? Potassium permanganate, right? So that's what we had started. Now, when I am talking about potassium permanganate, what is the oxidation state of manganese? What is the oxidation state of manganese in potassium permanganate? So that is +7. Right? Then we had manganate, potassium manganate. What will be the oxidation state? It will be +6. Can any one of you tell me, with respect to magnetic property, among these two, which is diamagnetic in nature? I'll be waiting for the answer. Among these two, which one will be diamagnetic in nature? I am waiting for the answer. Okay. Fast. Which one is diamagnetic among these two? This is permanganate. This is manganate. Mayank has already given the answer. Any one of you? Any one of you can give the answer? Fast. Among these two, which one will be diamagnetic? Mayank has already given the answer. It should be permanganate, right? It should be diamagnetic. And this one is actually paramagnetic in nature. Right? So manganate is actually paramagnetic in nature. All of you have understood? So that's where. Okay, now we people are giving the answer. Yes, permanganate is diamagnetic and paramagnetic is manganate. Fine. So that's where +6 and +7 oxidation state. So which type of structure they will be having? Whether trigonal or tetrahedral? Which type of structure they have? Which type of structure? They have the structure, geometry. Any one of you? Which geometry or which type of structure they have as a molecule? they should be having tetrahedral structure, right? So both of them, if you observe it carefully, central atom will be manganese and there are total 4 oxygen. That's where they will be having tetrahedral structure. This oxygen will be behind the board. Okay. So therefore they will be having tetrahedral structure. In case of KMnO4, any of these 3 oxygen will can make the double bond and one will be having negative charge. So therefore permanganate, it will be MnO4 minus. Right? So when it comes to manganate, where manganese once again act as a central atom which will be surrounded by 4 oxygen, which will be surrounded by the 4 oxygen. Now here any one of these 4, 2 will be making double bond. Any one of these 2 of these 4 will make the double bond. Other 2 will be having negative charge. So therefore when I am talking about manganate, it will be MnO4 minus 2. MnO4 minus 2. All of you have understood? So that's what we have discussed in the last class. The difference between manganate and permanganate. Okay? Now what is the speciality of permanganate? It can act as a strong oxidizing agent. Right? It can act as a strong oxidizing agent. We will come to that later. So before that we have discussed about preparation. We have discussed about the preparation. Right? So which mineral they will be using? It will be pyrolusite. It will be pyrolusite, where manganese oxide will be of high concentration, or pyrolusite is a mineral of manganese. Fine. So that's where we have the pyrolusite as the source. So what is the step 1? Step 1 is nothing but this pyrolusite, it will be treated with it will be treated with any one of you? Potassium hydroxide, right? It will be treated with potassium hydroxide in the presence of oxygen. All of you will agree? In the presence of oxygen. Now what will happen? They will get converted into K2MnO4, that is potassium manganate plus water. I have not balanced the equation because we have already discussed. Okay, so that's where we have pyrolusite, that is manganese oxide, when treated with potassium hydroxide in the presence of oxygen, they will get converted into potassium manganate. That was the step 1. Now when it comes to step 2, that's where we took some time, right? I took some time in balancing the equation, right? So now when I am talking about this one, MnO4 minus 2 in the presence of H plus. This is chemical method. Whatever I am talking is that is related to chemical method, especially step 2. We have another method also, which I told we are going to discuss it today. So now in the presence of H plus, it will get converted into final product, that is permanganate, right? So that is MnO4 minus. MnO4 minus 2 will become MnO4 minus. That's what we have discussed in the last class, right? So these are the reactions with regard to the chemical method with respect to step 2. In step 1, pyrolusite will be treated with potassium hydroxide in the presence of oxygen to give rise to K2MnO4, that is potassium manganate and water. So in step 2, chemical method, what they will do, whatever manganate they have got, they are going to treat with the H plus, that is acidic condition. Naturally it will be H2SO4, where it will get converted into permanganate, and another product will be in water, because H plus is here. To balance the hydrogen, we should have the water. So these are the concept which we have discussed in the last class. All of you will agree? Okay? Any doubt? Now another method here is, normally for commercial preparation, they can see the board, na? So for commercial preparation, okay, for the commercial preparation, once again we have the pyrolucite. They are not going to change the this one source, it will be pyrolucite only. That is step 1, it will be common. Pyrolucite, it will be treated with potassium hydroxide. In the presence of potassium nitrate. That is one thing. It will be extra in the presence of potassium nitrate. Okay? So they are going to have the fused condition. That means they should maintain the high temperature. So that's where what will happen? Same product, that is K2MnO4. So they are going to get the K2MnO4, and another product will be KNO2. Because potassium nitrate they have used, so they are going to get potassium nitrate. So this is potassium hydroxide. Okay, so whatever is here, it is nothing but potassium nitrate, and this is potassium nitrite. This is potassium manganate. So this is manganese oxide, or we can call it as pyrolusite, manganese dioxide or pyrolusite, right? So this is step 1. All of you have understood? This is nothing but step 1. So we may have to balance the equation. So now, if I go with manganese, fine, no problem. But if I go with potassium, there are 3 and here it is only 1. So I will make it as, okay, I will make it as 2 because KNO3 is there. I have written it on the arrow. So KNO3 is there. So I will make it as 2. So now why I have done for KOH only, why not KNO3? Because nitrogen is 1 and 1. So we will see. So in that case, we have the hydrogen which got balanced. 2 hydrogen, 2 hydrogen. Now we have to talk about oxygen. So 2, 2, 4, 7. Okay, fine. It is balanced. It's a bit student friendly equation. So it is balanced. So this is another method. So where we can call it as electrolytic method. Okay, we can call it as electrolytic method, especially when it comes to step 2. Okay, so when it comes to step 2. Step 1, it is fine. It's almost same as that of the earlier method. So manganese dioxide, once again source is pyrolusite only, treated with potassium hydroxide and potassium nitrate. Like hydrogen nitrate, we have the nitric acid, right? HNO3. So where nitrogen belongs to group 50. So 5 valence electron. So how many oxygens are there? There are 3 oxygen, right? So among that, 2 can make bonds like this. double bond, and one will be having negative charge. So therefore it will be binding to the hydrogen. That's where we have the HNO3. Okay? So that's where we have the HNO3 or KNO3, whatever it is. So therefore they are called as potassium nitrate. So here KNO2, potassium nitrite. Right? So potassium manganate and potassium nitrate will be the product. Now in step 2, as I told, it will go for electrolytic method. Any doubts in this? Because I will remove this so that I require some space. All of you have understood? Any doubt? So first step, it is same. Only thing here is potassium nitrate they will going to use in addition to potassium hydroxide. So next step is electrolysis. Okay, next step is nothing but electrolysis of manganate. It's not a chemical method, it's a electrolytic method, step 2. So it will be a electrolytic method. So electrolysis of K2MnO4. Right? So now when it comes to electrolysis, so what do you mean by electrolysis? Where there will be splitting of a molecule due to the passing of the electric current. So that's where K2MnO4, we can get 2 ions by this particular molecule. One is 2K plus a cation and another one is MnO4 minus 2 as an anion. All of you will agree? So we are going to have the K2MnO4 where it is going to give the 2 ions, 2K plus and one as permanganate ion. Okay? So this is potassium manganate, one of the product in the previous step in which we are interested. So this is manganate ion. Okay, na? So that's where we are going to have the 2 ions. Now when I am talking about electrolysis, electrochemistry, all of you have understood, there will be presence of 2 electrodes. Okay, so one will be having positive and one will be having negative. Right? Positive will be considered as anode and negative will be considered as cathode. Right? So that's where we have the anode and cathode. Now whatever potassium ion and whatever manganate ion is there, all of them they are present in the solution. All of them they are present in the solution. Among these two, which is anion, naturally it should be manganate will be acting as a anion. It is the cation, it will be the potassium ion will act as a cation. Fine? Now that's what we can understand. Now what will happen? Whatever manganate which is negatively charged, it will move towards the anode. Therefore it is an anion, therefore it is an anode. And whatever positive charge, that is cation, it will move towards the cathode. Okay, it will move towards the cathode. That's where we have the movement of these 2 ions to their respective electrodes. All of you have understood? So we are going to have the 2 ions due to the potassium manganate. One as potassium ion and another one as manganate ion. So potassium ion, since it is a cation, it has to move towards the cathode, and manganate, since it is a negatively charged, it is an anion, so it will move towards the anode. Fine? Now we will see at anode what will happen. At anode, why anode will be considered as oxidizing electrode? Because electrons will be moving away from the anode. If you remember, In electrochemistry, electrons will be moving away from the anode. Therefore, they will be given as a positive charge. So, electrons will be moving towards the cathode. So, therefore, it is a oxidizing part. So, now at anode, what should happen? So, whatever MnO4 minus 2 is there, it will donate the electron and it will become MnO4 minus. It will become MnO4 minus. So that means from plus 6, it has become plus 7. How many electron it has donated? How many electron it has donated? Mayank gave the answer. Any one of you? I don't know. My students, they have become silent nowadays. How many electrons it should donate? Or it has donated while getting converted from manganate to permanganate? First. Any one of you can tell me. And I think today's strength is also less. I don't know, number I am saying. Whether it's showing the proper number, I don't know. But any one of you can give the answer? Yes, Purnima. Very good. Mayank had also given the answer here. So that is 1 electron. It will donate the 1 electron and it has become manganate, has become permanganate. That is happening at the anode. Now at cathode. Now please remember that when I am talking about this particular molecule, we are going to have the 2 ions. But please remember at the same time, we have the water which can split as H plus OH minus also, because all of them, they are present in the water. So even water molecule is going to split as H plus OH minus. Now due to that, there will be a competition between K plus and H plus. Who are the good acceptor of the electron? They are going to win the race. What my point? There will be a competition between K plus and H plus. Anyway, while donating the electron, K2MnO4, that is manganate ion, has won the race. It has donated the electron. OH minus has not donated the electron. Now, while accepting the electron, once again there is a competition between 2 ions, K plus and H plus. But redox potential, we can tell that H plus is the good acceptor of electron compared to K plus. K plus is not going to accept the electron. It will be the H plus. So therefore, what will happen here is water will accept the electron and it will be donating, or it will be releasing hydrogen gas and OH minus. Okay, it is going to release the hydrogen gas and OH minus. So what is happening? How come hydrogen gas came? So in that case, we should be having 2 electrons. In that case, if 2 electron has to be donated, then 2 MnO4 minus 2 and 2 MnO4 minus has to be formed. Because to form the hydrogen gas, whatever H plus is there, each one of them will take up one electron, and then they are going to make the bond with each other and there will be release of hydrogen gas. So one water molecule will accept 2 electron to produce the hydrogen gas and OH minus. To produce the hydrogen gas and OH minus. All of you have understood? Whether I am clear? So even we can take, we can take it as 2 water. Yes, 2 water. So that's where we are going to get the hydrogen gas. All of you have understood? Any doubt? Any doubt in this? because one water will give one H plus, another water molecule will give another H plus, so therefore hydrogen gas will be released. So now what is happening at anode? For your competitive exam it may help you out. At anode there will be formation of KMNO4, and at cathode there will be liberation of hydrogen gas. Fine. So once again I will tell, for board exam electrolytic method they have not asked, very less. But another method they have asked, that is acidic condition. But all of you have understood how it will be done. So these are some of the things which related to commercial preparation of permanganate. These are some of the points that is related to commercial preparation of permanganate. I think it's there in your textbook also. So that's where we have the preparation of potassium permanganate. Any doubt? Any doubt? You can ask the doubt if you have. Otherwise, I will move to the next part. Okay. All of you are understanding, right? Whatever I am teaching. No doubt means I will get afraid. That's why I am asking. Okay. So we will move to the laboratory preparation. Laboratory preparation. So now, whenever we are talking about laboratory preparation, it can also be considered as small scale preparation.
In the commercial preparation, we used potassium nitrate, but we didn't use it in the electrolytic method. Step 2, we went back to potassium manganate itself. In the first preparation also we...
Okay, my question is, in first step, why not potassium nitrate, where electrolytic method is not there? In second step, why we are using? That is because in second step, we want infused condition. We want product in the fused condition. So therefore, we are going with potassium nitrate in the presence of potassium nitrate. It's a good question. So in case of, once again I will make it clear, his question here is, sir, in the first case we went with only potassium hydroxide and we were getting manganate, potassium manganate, but the same potassium manganate in second case we are using in the presence of KNO3. What is the reason? The answer here is, we want to have the product that is manganate in a fused form. We want to go with bit high temperature. Therefore, we are using potassium nitrate. But the product is same in both the cases. In one case, we are going to get permanganate only. In another case, we are going to get the manganate only. But conditions are slightly variable. Okay? So, that is the reason. Fine? All of you have understood? So, in that case, we will move to the laboratory method. So when I am talking about the laboratory method, as I told, it's a small scale preparation, which can also be considered as small scale preparation, where manganese ion, Mn plus 2. Manganese ion, it's understood that I am talking about Mn plus 2. It can be treated with persulfate. Persulfate. What is sulfate? Where I have the oxygen, oxygen, oxygen. Right? So H2SO4, SO4 minus 2. That is sulfate ion. Right? Sulfuric acid H2SO4, because 2 hydrogen to neutralize the minus 2 charge. Since sulfur belongs to group 16, 1, 2, 3, 4, it belongs to group 16, it can make another 2 bond. That's where they will have the negative charge. So that's where we have the negative charge. Now here I am telling that persulfate. Here I am talking about persulfate. So that means I am not talking about the sulfate, I am talking about the persulfate. Right? So what can be that persulfate? So that's where 2 sulfate attached by the oxygen, 2 oxygen, that means peroxide. 2 oxygen attached with the single bond, it is considered as peroxide, right? So that's where I am going to have the peroxide, that is persulfate. Since there is a bond between oxygen, single bond is there. So therefore it is a peroxide, like hydrogen peroxide. Last year, first PUC, you have discussed in hydrogen topic about hydrogen peroxide, where we have the oxygen attached with the hydrogen. Each oxygen will be attached with the hydrogen. So why they are called as peroxide? Due to this linkage. So here also it is there. So now, since it has been resulted due to interaction of 2 sulfate, so therefore it is called as persulfate. Fine. Now hydrogen persulfate, then I can write it as 2 hydrogen. Potassium persulfate, I can write it as K here. So that's where we have the persulfate ion. So what should be the formula for persulfate? So it should be S2O8 minus 2. Right? So S2O8, total 8 oxygen minus 2. Since I am going with the ionic form or ionic equation, since I am going with the ionic equation, I will go with the S2O8 minus 2. That's where we have the persulfate. Fine. Now, in that case, when I am talking about persulfate, what is the speciality? Like any other peroxide, this bond can be undergoing for homolytic cleavage. It can form the homolytic cleavage, where it will result in the formation of radical. It results in the formation of radical. Right? So therefore immediately they can take up one electron and they will become sulfate. Immediately they can take one electron and they can become sulfate. O minus, O minus, O minus, O minus. That's where we have the persulfate. All of you are understanding mechanism? No one will ask. Please remember, I wanted you to know how come this formula came. S2O8 minus 2. It came from this particular molecule. So that's where there will be formation of sulfate. So one of the product should be sulfate, right? So that is SO4 minus 2. How many sulfate? 2 sulfate should be there. Okay, it should be 2 sulfate which will be formed. For time being I am writing. Now, next, this Mn plus 2 will become MnO4 minus. Mn plus 2 will become MnO4 minus. That's where we have the permanganate. So this is sulfate ion and this is permanganate ion. Okay, permanganate ion. If you have any doubt, you should ask. Don't keep quiet. So that's where we have the permanganate ion. Any doubt? So why this persulfate? How come it became sulfate? You got the answer? So that's where we have the persulfate. A common reagent, persulfate. In PU level they will not use. But when it go for higher studies, basic chemistry or chemistry if you have taken, then you will utilize these reagents. Okay, that's where we have the persulfate. Fine? So now we have to use water molecule to balance the equation. Otherwise this equation cannot be balanced. We will come to know that one. Okay? Now, since it is a redox reaction, from plus 2 it is becoming plus 7. From plus 2 it is becoming plus 7. Okay? So that's where we are going to have the reaction. Now in that case, can you tell me how many electrons should be given by the Mn plus 2 to convert S2O8 minus 2 into sulfate? First. If you want to calculate, you can calculate. S2O8 minus 2, that is minus 2. But please remember here, 2 oxygen, they are directly bonded to each other. Here, 2 oxygen, they are directly bonded to each other in persulfate. And in peroxide, what is the oxidation state of oxygen? Wow. It is minus 1. In peroxide condition, oxidation state of oxygen will be minus 1. And I told 2 oxygen, they are bonded directly to each other. 10 minutes. So total, since there is involvement of 2 sulfate, since there is a formation of 2 sulfate ion, so there will be requirement of how many electrons? 1 persulfate is getting converted into 2 sulfate ion. Rest of the oxygens are remaining same. Only that 2 oxygen are getting changed. How many electrons? Fast. Wow. I showed you the reaction also now. Only those 2 oxygen, they are going to accept the electron. Rest of the oxygen will remain same. So 1 persulfate is getting converted into 2 sulfate. They require 2 electrons. Normally they require 2 electrons. So that means 1 manganese ion is donating or losing how many electrons? It is losing 5 electrons. It is losing 5 electrons, right? So 1 manganese ion. So in that case, here already 2 sulfate is there, right? So Mn plus 2 getting converted into MnO4 minus plus 5 electron, S2O8 minus 2 getting converted into 2 sulfate in the presence of 2 electrons, right? So multiply the equation, multiply this one by 2, multiply this one by 5, so that we have to balance the electron. I told now only 2 electron it requires. Only those 2 oxygen which are bonded to each other, they are going to accept the electron. So therefore, how many manganese ion? It should be 2. How many permanganate ion? It should be 2, right? So how many persulfate ion? It should be 5. How many sulfate ion? Already 2 is there. So therefore it should become 10 sulfate ion. It should become 10 sulfate ion. All of you have understood? So that's where we have the redox reaction. By using oxidation number method or half reaction method, we can balance this particular equation. Now only thing here is oxygen and charge we have to see. we have to balance. Okay? Now, if I go here, how many oxygen is there? 4, 0, 8 5s are, right? 4 oxygen is there. Here, 8, 40, right? 40 and 8. So that means 48 oxygen is there. That means I have to make it as 8H2O. I have to make it as 8H2O to balance the oxygen. So how many hydrogen? 16. So I will make it as 16H plus. That's where I have balanced the equation. All of you have understood this one? Any doubt? By using redox method or half reaction method or oxidation number method, we can balance the equation. We can balance the equation. So this is where we have the laboratory preparation of potassium permanganate. All of you have understood? Any doubt? Fine. So what we have done is, how much manganese has lost the electron, manganese ion? It has lost 5 electrons. So how much persulfate requires to get converted into sulfate? That's what I told. If you recollect, these 3 oxygen, there is no change. These 3, they are not going to do anything. So these 2 are the one which will undergo for homolytic cleavage, and later they are going to accept the electron. So these 2 oxygen, that means 1 persulfate will get converted into 2 sulfate by accepting 2 electron. Since manganese ion is donating 5 electron, naturally it should be multiplied by 5, and manganese, this should be multiplied by 2, cross multiplication, to balance the number of electrons, which you people have studied in your redox reaction method. In redox reaction topic, you people have practiced to balance the redox equation. That's why it's going to help you out now. Fine? So that's where we have the laboratory preparation for potassium permanganate. Okay, na? So preparation of potassium dichromate is very important, and even preparation of potassium permanganate is important. But potassium dichromate, many times they have asked. Okay? So shall we move to the next one? That is properties. Chemical properties of, we are moving to chemical properties of KMnO4, potassium permanganate. Chemical properties of KMnO4. Fine? Now, when I am talking about chemical properties of KMnO4, as I told, it's a strong oxidizing agent. It's a strong oxidizing agent. But before that, this KMnO4, it can be undergoing for a reaction at a temperature, bit high temperature. It can undergo a reaction at high temperature in such a way that where it can become K2MnO4 plus MnO2 plus any other product. It will be oxygen. It will be oxygen. Now we will make it as 2. Okay, student friendly equation. It got balanced. Which type of reaction it is?
Decomposition.
Approximately above 510 Kelvin, 515 Kelvin.
Decomposition.
Okay. So according to Mayank, it is a decomposition reaction. Yes, fine. Anything extra you want to add? If I say manganese is in plus 7, then plus 6, here
Plus 4.
plus 4.
Reduction rate.
Plus 4 in a reaction, in a redox reaction or in a reaction where element will be in more than 2 oxidation state, then it is called as,
But that should be, one should be oxidation, one should be reduction.
no, any one element, if it is in more than one oxidation state, then we can call it as disproportionate reaction. Then we can call it as disproportionate reaction. Fine. So that's what we can observe. Okay. So this what will happen? This one will happen when potassium permanganate is exposed to higher than 510 or 513 Kelvin. So that's where it's going to form potassium manganate. This is nothing but potassium manganate. And this is manganese dioxide. Don't write it as pyrolusite. No. Potassium dioxide. And this is potassium permanganate. This is where we have the potassium permanganate. So here also there is a liberation of oxygen. Okay? All of you have understood? So this is what will happen when potassium permanganate is exposed to high temperature. Now another thing here is, now I will come to oxidizing property of the KMnO4. Now when I am talking about oxidizing property, especially it will be acting as a strong oxidizing agent. It will act as a strong oxidizing agent, especially in the acidic condition. It will act as a strong oxidizing agent under acidic condition. Under acidic condition. And acidified KMnO4, acidified KMnO4, it will be prepared with dilute H2SO4 only. No utilization of HNO3, no utilization of HCl. Please remember, there is no question of utilization of HCl and HNO3. Always it will go with the H2SO4 for acidic condition, to get the acidic condition. Fine, all of you have understood? Now what will happen? Why not HNO3? It will be not used. What is the reason? Because HNO3 itself, it will act as the oxidizing agent. Itself, it will act as a oxidizing agent. So there will be a competition between KMnO4 and HNO3 to show that oxidizing character. So therefore HNO3 will not be utilized. Acidified KMnO4, HNO3, nitric acid will not be utilized. Why not HCl? Why not HCl? That is because if I take HCl, it's going to form KCl, manganese chloride and chlorine gas plus water with KMnO4. That means HCl itself, it will going to react with the KMnO4. So these are some of the points which may help you out in your competitive exams. Please remember. So potassium permanganate, acidified potassium permanganate, always it will be prepared by using sulfuric acid. There is no question of nitric acid, because nitric acid itself, it is an oxidizing agent. So they are not going to use the nitric acid. Then they are not going to use the HCl because HCl, which is a mild reducing agent, even itself is going to react with the KMnO4 to form this salt and chlorine gas. There will be liberation of chlorine gas. So due to that, they are not going to use the HCl. All of you have understood? This one anyway, this is not there in your textbook. I have not balanced the equation. So all of you have understood these are the reasons why acidified KMnO4 is always go with the sulfuric acid. Okay? Now the question here is, how acidified KMnO4 will be prepared? You got the answer. That is by using H2SO4. Now the next question is, why acidified KMnO4 will act as a oxidizing agent? To answer that reaction, this is where we have the KMnO4. When it is present along with the sulfuric acid, now there will be formation of K2SO4. That is quite natural because sulfate -2, to neutralize the 2 charge on the sulfate, 2 potassium is required. So potassium sulfate. Any other product? We have discussed similar reaction with potassium dichromate. Any other product?
Manganese sulfate.
It will be manganese sulfate. Whether I should write it as Mn2SO4 or MnSO4. Manganese sulfate. Whether I should write it as MnSO4 or Mn2SO4.
MnSO4.
It should be MnSO4 because one manganese itself, it will have the 2 positive charge. So that's where we have the manganese sulfate. Any other product?
Water.
Okay, because hydrogen is here, but on the right hand side there is no hydrogen, water. Any other product? Because similar reaction we have discussed with potassium dichromate. Any other product? That means there will be formation of nascent oxygen. There will be formation of nascent oxygen. So due to that, it will act as a oxidizing agent. That can be one answer. And if you observe it carefully, manganese from +7, it is becoming +2. Manganese from +7, it is becoming +2. Right? So that's where under acidic condition, permanganate ion will get converted into manganese ion. It's going to lose how many electrons? 5 electrons. It's going to lose, or it's going to accept 5 electrons. Strong oxidizing agent. So we have to balance the equation. Potassium 2 is there, so for time being I will make it as 2. Now manganese, so I will make it as 2. Now H2SO4 sulfate on the right side it is 3, so I will make it as 3. So hydrogen,
Right side is 4.
right side, no 3 only na. Okay, so we will see, it's not final one, we will see. Now we will see potassium 2, manganese 2, sulfur 3. Now what is left over? Hydrogen. 3 2 is 6, 3 2 is 6. Left over is oxygen. Why I am going last for the oxygen? Because we have the pure form of the oxygen. So therefore I am going it for last one. Now oxygen 4 2s are 8 and 12, that is 20 oxygen on the left hand side. And here it is 8 plus 3 plus 4 and plus 1. That is 16, right? So it will become 16, right? Whether I am right? So in that case, how many nascent oxygen I should make? Five nascent oxygen. So I should make it as 5 nascent oxygen. So that's where I have got the balanced equation. So this is the answer for the oxidizing character of potassium permanganate under acidic condition. Any doubt? So any doubt in this? How many oxygen, nascent oxygen is getting liberated? 5. Okay. So that's where we have the oxidizing character of potassium permanganate. This is the reason why I have given the answer for why. Now I have to justify. I have to give some examples on what basis we can prove that yes, potassium permanganate under acidic condition it will act as a strong oxidizing agent. But what you should remember here is conversion of manganese from +7 oxidation state to +2, because manganese sulfate is nothing but where manganese is with +2 oxidation state. Okay, in permanganate manganese is with +7 oxidation state. That one you should remember. Okay, anyway, I will stop here. But before closing the class or closing the session, I have doubt. In the beginning, I saw my students, they were very curious. They used to ask so many questions. And if I remember, 1 or 2 times I told, I will look into that and will come back to you, right? So in that way, what will happen here is, it should be like both the ways. Even teachers can learn from the students. Not only students, they are going to learn from the teachers. If a good student is there, who is having interest in the subject, so during that time to teach or to talk to those type of students, a teacher has to prepare double. So in that way, even teacher can enhance his knowledge. Knowledge cannot be 100% for anyone. Always it will be going on. It's a learning. Everyone is going to learn. But I want to ask why my students have become silent. And I think today a bit less attendance also. That is fine. But I want answer for my first question. Why people have become silent? Good morning, sir. That is fine. But after that, I don't think any conversation. Right? So first thing, whether you people are understanding what I am teaching, you should be frank enough. Sir, ನಮ್ಮ ಹೆಸರು ಬಂದ್ಬಿಡುತ್ತೆ sir. No. Always I will be telling to my students, all the fingers will not be same. They will be of different size. Same way, whatever Raghavendra sir teach, it should not 100% it should reach to each and every one student. If you tell frankly, I can change wherever it is required. And please inform to your friends also to attend the class. Okay? Don't keep postponing. These whatever outside environment is there or condition, it will be there. That's where it's life. We should not get affected by all those things. Okay? So in that case, shall I stop? Shall I stop the class if you don't have any doubts? So tomorrow we are going to have some more reactions by which we are going to justify the oxidizing character of potassium permanganate.
So potassium permanganate is more stronger oxidizing agent than potassium dichromate.
Okay, you are comparing. Okay, my own question is whether potassium dichromate and potassium permanganate, which is strong oxidizing agent. That one you will come to know. See, for example, KMnO4 under acidic condition, it is becoming Mn+2. Same way, K2Cr2O7, it is becoming +2. Because if you remember, chromium sulfate, right, Cr+2. What is the oxidizing character? It is plus 7. Here, plus 6. That means from plus 7 it is becoming plus 2. How many electron it should take? It should take the 5 electron. How many electron? It should take 4 electrons. That means if I take individual 1 molecule, under acidic condition permanganate can accept more electron compared to dichromate. Yes, with number of electron we can tell KMnO4 is dominating. But what will happen here is depending on the required condition, people will use either potassium dichromate or potassium permanganate. But as a molecule, if I consider, yes, permanganate is going to accept more electron. That is because of the manganese. Here it is chromium. Fine. So that's why. But otherwise, both will be considered as a strong oxidizing agent only. Okay, both will be considered as strong oxidizing agent. Okay. So any other doubt? Okay. So in that case, I will stop here. Thank you. Take care. Bye.